Let's look at some examples of how to apply this definition and properties of the natural logarithm in 7.2. So next we want to do implicit differentiation with logarithms, and then we'll do what's called logarithmic differentiation. So here, this is just a recap or recall how to do implicit. So if you have something like that, you could, on this one, solve for y in an explicit form, but it'll have a plus or minus square root in there. Otherwise, you can do it implicitly. So if you differentiate implicitly, then what you do is you take the derivative, but it's with respect to y, so you got to use chain rule. So this would just be 2, so you do the derivative, which is 2y, and then times the derivative of y. So you say then y prime. And it's plus, and then derivative of 2x is just 2, and derivative of 5 is just 0. And then you would solve for y prime. So y prime is going to equal -1. So you subtract 2 on both sides, divide, and you get -1 over y. And y was not solved for in the beginning at all, so you would just leave it like that. Okay, so that's just a recap. So this is using log differentiation. So suppose you had ln xy plus 5x equal to 30. Find y prime, dy dx. So if you were to take the derivative of ln x y, you'd have to use, first you do 1 over xy and then times this derivative, which would be the product rule. Or you could simplify this and just break that apart. That's ln x plus ln y plus 5x equal to 30. So you can use properties of logarithms to help you simplify it. So now that's just, okay, so now differentiate. So now differentiate with respect to x. So that's, so now you're saying, just let me rewrite it for us like this. So you're saying dx of this whole thing, and then ddx of the 0, which is just course 0. So that's just 1 over x, and then that's it, times 1, plus 1 over y, and then what? Times y prime, and then plus 5, which equals 0. Okay, so now solve for y prime. Multiply through by the LCD, and you get y plus xy prime plus 5xy equal to 0. I'm going to have to go across here, save some space on the display. So that's equivalent to xy prime equal to negative 5xy minus y, bring everything over. Now divide by x. So y prime is equal to negative 5xy minus y over x. And then you could maybe factor out the negative y or something. So let's just say y prime is equal to negative y 5x plus 1, it's messing up a little bit, over x. Okay. So that's implicit diff with logarithms. So it's just using techniques of logarithms. Now we're going to do what's called logarithmic differentiation. So let's take a look at that. Okay, so this is something that does not have a logarithm in it, and then you take the log of both sides to simplify it. So this is called logarithmic differentiation. So what you're going to do is take the natural log on both sides to simplify it. So for example, suppose you have y equal to the square root of, it's often kind of messy, x squared minus 1 over x squared plus 1. Do something like that. And then we're going to take ln on both sides. So take ln on both sides, and you get ln y equals, and this really only works if the right-hand side is positive. I mean, you do have to have some hypothesis going on here, but they kind of ignore it. But this is positive, so you can have ln of that positive number. So you get ln of that root, and then it'll be a half, so you just factor it out in front. So x squared minus 1 over x squared plus 1. Okay, so now you apply properties to simplify. So you get ln y equal to, and then I'll do this. Basically, you're going to bring out the half and then separate the what's inside. We had this before, basically. So it's ln, and then you can use a bracket there. Ln x squared minus 1 minus ln x squared plus 1. So now differentiate both sides. Trying to give you some outline here, how to do them. So that was our technique. Let's see, where I didn't actually say it here. So given that, put that over there. Find y prime. Clean this up a little bit for your notes. So yeah, so take the log of both sides. Okay, and that's your first step. Okay, so all right, so now let's do that. Okay, so now differentiate. So we did that. Okay, so apply properties log. Now differentiate both sides. So that's going to be left-hand side is 1 over y times y prime equal to a half. And then this becomes your 2x over, right? Because 1 over x squared minus 1 times its derivative. And then minus 2x over x squared plus 1. And we just want to simplify that. So that's going to be equal to, I went ahead and sped this up a little bit. It's a half, and then you simplify it like this to verify this. You get 4x over, didn't we just do this one? Yeah, we just did it. That's why I know it. Okay, so remember we just did this. So that's this up here. But this had a 3 because it was a cube root. So this is a 2. So it's the same form. It's almost the same one we just did. So we can see here that reduces. So 4 and the 2 reduce right there. Excuse me. So you get x over x to the 4th. Oh, no, that's a 2. Okay, so 2x over x to the 4th minus 1. Okay, so that is your y prime. Multiply through by y, so you get y prime equal to your y times all of that, which is your 2x over x to the 4th minus 1. And then now you can substitute for y because you know what y is. Y is that root. So I'd probably interchange those. So I'd probably go ahead and say 2x over x to the 4th minus 1 times that root. Okay, so you get x squared minus 1. Am I going really slow tonight? I don't know. You can speed it up. Over x squared plus 1. Okay. So that's logarithmic differentiation, where you take the log of both sides and then simplify it. Okay. I have a couple more, then we get into some integral formulas. All right. Okay, next one. So try this one. Wait a second. We already did that one. Oh, I see. All right, well, let's do another video.